So good afternoon all. Today we are going to deal with the analysis of a plate with a hole. Okay, so these are the dimensions of the particular plate: 100 mm, 200 mm along the horizontal. There is a hole of radius 10 mm, and it is acted upon by a pressure of 10,000 Newton per millimeter square. The properties of this plate is given as Young's modulus is 2.1 into 10 raised to 5 Newton per millimeter square. The thickness of the plate is 5 mm and the Poisson's ratio is 0.3 mm. Okay, so now let us start with the abacus. So first of all, launch the abacus. Select the model database as standard explicit model. So first of all, we have to set the work directory. Select the work directory. So I am setting this folder as the work directory. So now I am going to create the part. So it is a 2D planar model. The approximate grid size should be 500 because the horizontal dimension is 200 mm. So I am setting the approximate size as 500 mm. Okay, now I am going to create a rectangle. Dimensions of the rectangle is 200 mm by 100 mm. I am also creating the hole. Now I am going to add dimension 200 mm. This is 100 mm. This radius is 10 mm and it is located exactly at the center. So this is 50 mm and this dimension is 100 mm. Okay, so now our drawing is ready. Now we have to create the part. So click on done. Our part is ready. Next, go to property module. Create material as steel. Elasticity. Elastic. Young's modulus as 2.1 E5 and the Poisson's ratio as 0.3 and click OK. Now create the section homogeneous. Continue. Enable plane stress condition and the thickness be 5 mm. Hope you are aware about what is plane stress condition. Then click OK. Now you have to assign the section. So click on the part, click on done. Section is there which we have created earlier. Then click OK. Now go to assembly module, create part instance, make the part independent, click on OK. Now go to step module, create load step, static, click on continue, OK. Next, create field output, click on continue. What all are the results we are interested? We can see that we are interested in maximum displacement, 1 measure stress, strain and reaction forces. Click on 1 measure stress, then the strain, then the displacement and finally the reaction forces. So all of the results which we are interested has been requested in the field outputs. So click OK. Now go to step module over, then go to load module. So click on create load. So we are applying as a pressure. Click on continue at this edge and the magnitude is minus 10,000. Okay. Next, click on create boundary condition. Here mechanical. Click on symmetry or anti-symmetry or encastre. Click on continue. Then select the edge. Select this particular edge. Click on done. So in that we are arresting all motion at this particular edge. Okay, so u1, u2, u3, ur1, that is the rotation about that particular x-axis. rotation about the y-axis and rotation about the z-axis. All of these 6 degrees of freedoms are arrested. So select encaster and click OK. Okay. Now click on mesh. First we have to select the element type. So click on done. You can see that we have to select the plane stress element. So plane stress element is already selected. So we will be using quad element as CP-S4R. It's a four noded bilinear plane stress quadrilateral element, and triangular element as a 3 noded linear plane stress triangle element. Okay, CPS3. Now click OK. Now go to seed part instance. Let the element size approximate global size be 5 mm and click OK. Now assign mesh controls. Okay, before that mesh part instance. So yes. So we can see that these are the triangular elements and these are the quadrilateral elements. Both of these have been used in this particular analysis. So this is somewhat unstructured thing. So let us make it something structured. So quad dominated. Select the algorithm as medial axis. Okay, click on medial axis, click on OK. So it will be asking whether we have to delete the previously generated mesh. So click on delete meshes. Again you have to go to mesh part instance, click on part instance. Okay, so somewhat it's again a structured mesh. So if we reduce the size of the element further, we'll be having a much more better mesh. So now go to job, create job, click on continue, OK. Then job manager, click on submit. Now we can see that the job has been completely evaluated and click on results. Okay, so now you can see that the stress distribution of this particular plate due to the load. Next we have to check the displacement. So this is the displacement profile, the strain profile, and the reaction force. Okay, so next we have to generate the report. Click on report, field output, select the unique nodal. Here we are interested in the strain, then the reaction force magnitude, then the von Mises stress, then the magnitude of the displacement, and where the file to be. It is in the default folder and I am naming it as plate. Okay, now click OK, click OK. So now you can see that it's there in our default folder, work directory. So here the total number of nodes is 886. Total number of nodes is 886. These are the maximum number of values, maximum values of stress, displacement, strain, and reaction force. And one more thing, number of elements. The element size we have given us the element size, it's already given as 5 mm, and the mesh part instance, click on yes. Now you can see that at this particular point 821 elements are there. Okay, 821 elements are there altogether in this particular analysis. Okay, So the results, element name is there, element size is there, total number of elements, total number of nodes, maximum displacement, maximum moment stress, maximum strain, maximum reaction force. All these things has to be updated. And thank you.